Hello everyone. Uh, this video is going to be on the Army Corps of Engineers Antecedent Precipitation Tool. So this is part of the wetland delineation process for the Army Corps of Engineers. And wetland delineation, recall, is essentially specifying where the boundary between a wetland and the upland is. So in particular, on the data form, and this data form shows the Western Mountains, Valleys, and Coast Region data form, but the top of the data form has a couple questions that this tool may help us address, including are climatic slash hydrologic conditions of the site typical for this time of year? Um, there's also the question of are normal circumstances present? So this antecedent precipitation tool will really help with the climatic and hydrologic conditions being typical, but it also plays into the normal circumstances question. So I'm going to skip over those slides that explain other parts of the top of the data form to skip ahead to the normal circumstances portion and then the typical conditions. So I do have a link here for it's a sort of a presentation that explains what is meant by normal circumstances and how you can evaluate that and answer that question. But as I said, this does tie into the question of are climatic and hydrologic conditions on the site typical for the time of year? As it relates to this question, not typical conditions would be that you are in the dry season when you're doing the delineation, that it's drought conditions, that there's lower than normal antecedent precipitation. Antecedent precipitation is simply recent precipitation, or that you have greater than normal antecedent precipitation. So, related to these questions about normal circumstances and typical conditions, how do we determine how to answer those questions? Well, there's two approaches that you can take. You can look at existing data or models for the wetland or the watershed that you're working in, and that can help you answer those questions. But not all wetlands and watersheds have flow data or other sorts of data that might be helpful in answering these questions, and that's where the antecedent precipitation tool can come in really handy. So this tool was developed by the Army Corps of Engineers, and it is essentially a standardized methodology for allowing comparison of the antecedent or recent rainfall conditions at a given location compared to normal rainfall conditions for the preceding 30 years. The way it does this is it pulls precipitation data from weather stations that are within a NOAA network, so it is validated data, and it compares the previous 3 months from where you specify to the same 3-month period of the preceding 30 years. And it's actually a rolling 30 years. So if things change climatically, this will account for that because it's just looking at the previous 30 years. So 30 years down the road, when we are possibly dealing with impacts, or well, not possibly, if the climate and weather trends have changed due to climate change, this tool should be able to account for those changes. In the end, it ends up outputting a lot of things, but really what it comes down to is creating an index score that tells you if you have atypical conditions or if it's typical conditions. And again, we would use this tool when flow measurements or models or other data do not exist for a given location. This is a software package that you do have to download and install on your computer. For the purposes of my course that I teach, you do not need to download and install it. I will run this tool for the whole class, and then you can just use the index score that I produce when I run it to answer those questions about normal circumstances and typical conditions. But for other users or for people that are curious, this website here will take you to where you can download it, and it gives some brief instructions on how to download it. So just very quickly, this is what the website looks like, and you can see you can download it here. It is a zip file, so you do also have to download this 7-zip software to unzip that folder and then to install it. So in my opinion, it's a little bit of a pain to install, and that's one reason why I'm not requiring my students to install it. But that being said, I was able to figure it out based on the instructions that they provided here. Once you do install the tool, it looks sort of like this. So it sort of runs in like a DOS type of setting or something like that. But there's also another window right here, and that's where you actually enter in your location and the date or dates that you're interested in. The tool, once it runs, creates a PDF report that includes a graph, the index score, and the weather stations that it pulled data from. So this is one that I did a couple days ago for in the Tacoma area for the Flet wetland. And this is in May of 2021. So you can see that in January, the rainfall was well above average. So this yellow in the graph is the 30-year normal range. So, and the blue is the rolling total over the past 30 days. So you can see January was pretty above average, but March, April, and May has been a fair amount below average. The index score, which is located right there, it's a number from 0 to 15 or above. If you are 9 or lower for the index score, conditions are considered drier than normal. If you're between 10 and 14, conditions are considered normal. And if you're 15 or higher, conditions are considered wetter than normal. So if you were in this 9 or lower or 15 or higher range, you would have to say that conditions are not typical for that time of year, because it's either drier than normal or wetter than normal. So with that, I want to very quickly show you how to use the Antecedent Precipitation Tool. So like I said, it pulls up in this window and it's ready for input. And you input in this smaller window here. So you can see it asks for latitude, longitude, and scope. So if you're just doing a single point, you enter latitude and longitude, and it's asking for it in decimal degrees. And I'll show you the easiest way to get latitude and longitude decimal degrees. You can use a GPS unit, but if you know your location and can find it on Google Maps, that's probably the really easy way to find it. You also have the ability to select based on watershed, so you can use HUC 8, HUC 10, or HUC 12 for watershed boundary, or you can upload a custom polygon, so you can actually upload a shapefile if you have a shapefile from ArcGIS. But I'm just going to do a single point. So you need latitude, longitude, and decimal degrees, and the date that you're interested in. You can also do multiple points at a time, so you can add more points or more dates. Looks like more dates in particular. Yes, so you can add different dates. I'm just going to do a single date. So I am interested in the flat wetland, which is here in Lakewood, Washington. And part of the flat wetland in this area is part of the Clover Park Technical College outdoor lab facility, which is where I currently do my wetland delineation practice with my students. So we normally do it on the north side of the wetland. So I'm just going to click here. And if you go to Google Maps in your web browser and you just click the particular location on the map, it will give you, and if you sort of click at the same spot twice, it'll give you the coordinates right here. So I am going to pull that off to the side so that I'll be able to see it in my Antecedent Precipitation Tool and enter it. So we have 47.18 1517 as the latitude, and then the longitude is a negative number in decimal degrees. It's negative 122 point, let's see, that's 501668. For the date range, today's date, it's 2021. The month is 05 for May, and the day is actually 28. So if I put in 28, what you will see is input error. The data, the precipitation data, is 2 days old. So you have to, in other words, they don't quite have today's precipitation data, obviously, because the day is not over. And they also don't have yesterday's. And I think part of that is because just data validation. So you do have to jump 2 days back from your current day. So I just have to change this to the 26th. And then I hit calculate. And it will contact the server and download the precipitation data. So it's going to just scroll by. And it's the first thing that's doing here is searching for weather station within 30 miles. And then once it finds those 30 those weather stations, it's going to look to see which of them have the data that's necessary. So data for the last 3 months, and then data for the last 30 years during that same 3-month period. So we're going to be looking at March, April, and May, and we need that data for obviously 2021, but we also need it for that same March through May time period for the previous 30 years. So going back to, I guess would that be 1991 if I did my math correctly? And you can see it does take some time for it to download and process the data from those stations. So I'm just going to hang tight, and then I will delete this wait time in this video and show you the output. Okay, so it can take, several minutes for it to do its thing, and it does open up a PDF for you. The other thing that it does is it does put the PDF itself along with the weather station data as CSV files, I believe. Yep. In a folder that's specific for that location. Within the Antecedent Precipitation Tool folder on your computer. So you can go back and access that. And it's sort of handy because it does do it based on the coordinates. The folder is named based on the coordinates. So if you're having to do a lot of these for different locations, it's sort of easy to find the particular coordinates that you are looking for if you need to go back and get this report. So this is similar to what I had in the PowerPoint slides, because I just had done that one a few days prior to this one. So important things to point out. Here is your index score. So it's a index score of 6, which is drier than normal. So we would have to say that um, we do not have normal circumstances, and we do not have typical conditions for this time of year. Um, it also provides a drought index from the PDSI drought index. A mild drought in April, which you can definitely see in the data in the graph. And we are also in the dry season for Washington State, or entering the dry season for Washington State. Um, but you can see the fact that there is a little bit of a drought in late March and April, throughout the months of April, on the data. So the yellow is the range for the 30-year normal range for this region, and the blue is the 30-day rolling total, and you can see that is the blue line is outside of that 30-year normal range during the months of March and April, and even into May. So that's it for the antecedent precipitation tool. I think it's a really cool tool, even outside of wetland delineation, but it's definitely handy for those that need it in the Army Corps of Engineers and the wetland consultants that are doing wetland delineation. Uh, but even if you're just curious about what your what the year has been like for your area in terms of recent precipitation, this graph that it outputs is pretty easy to interpret and to visualize what the precipitation trends have been over the past 3 months. If you do have any questions, please do feel free to reach out to me. I'd be happy to try to help. I don't necessarily consider myself an expert on this tool, but it, in my opinion, is fairly user friendly once you get it installed. There's not a whole lot of data that you need to input to get it to run and calculate. Have a day gray in the wetland.